Hi, this is Mrs. Meltretter with the Chemistry of Life Notes, Part 1A. So we're going to break this up into a couple different pieces. So here we go. So why are we studying chemistry in AP Biology? So living things are made up of elements, which chemistry, right? Molecules and compounds. And our metabolism as humans and other animals is the sum total of all the reactions that are taking place in your body, all of the chemical reactions taking place. So I often think, this is my cute little girl, Luna, and I think about like how her body chemistry keeps her alive and all of the different things that have to happen for her to react to me coming home. You may have some examples yourself. So we're going to start with the idea of matter. All organisms are composed of matter, which is anything that takes up space and has mass. So there's lots of forms of matter. I listed a few. Can you think of some more? Matter is made up of atoms, and atoms are the smallest piece that matter can be broken down into. An atom has some certain properties that all atoms of that element will have. Okay. Inside or as part of the atom, there are different pieces. One part is the nucleus, and then the other part is the orbiting shells. Inside the nucleus, you have neutrons and protons. Okay. Neutrons have a zero charge or no charge, and protons have a positive charge. Electrons, those orbit around the nucleus, and we always picture them as pretty close, but actually they're really, really far away from the nucleus, and those have a negative charge, and they have almost no mass. Okay. There are elements that we will study or go through in AP Bio, and most of those will come from the first 20 elements. Those are the ones that we'll use the most, and even at that, we only use hydrogen, carbon, nitrogen, and oxygen more than any of the other ones, maybe a little phosphorus in there too. So elements are made up of atoms with the same chemical properties that can't be broken down. There are 90 naturally occurring ones. All atoms of an element have the same number of protons in their nucleus. So if we look at this description here, carbon is, sorry about that. So the atomic number up here, so carbon is 6, that's going to equal the number of protons inside of that nucleus. It's also going to equal the number of electrons. So carbon has 6 electrons orbiting around it. Okay, and here's a copy or a cut and paste from a periodic table, and it's labeled. So your atomic number of 1, this happens to be hydrogen, H is the symbol. This is the number of protons, and then it would also have 1 electron, and the relative atomic mass is 1.01. Okay. So the mass number or atomic mass is the sum of the protons and the neutrons. And remember, again, neutrons don't have charge to them. So then we get to those different forms of the same element, and those are called isotopes. Sometimes you have different numbers of neutrons in that nucleus. So maybe that carbon that would normally have 6 neutrons will have 7 or 8 neutrons. Most of the isotopes will behave in a way that's similar to the original element, but sometimes they behave differently. So radioactive isotopes are those that can lose particles and decay and give off energy as they decay. So carbon-14, which is carbon but with a couple extra neutrons, decays to nitrogen when it loses a proton. Okay. And we're not going to have to worry about the radioactive ones, I only bring those up because they can use radioactive isotopes to detect certain types of cancer and things like that. So we won't focus on knowing them, but it's worth mentioning. Okay. Then we have the elements of life. We'll be focusing on a lot of the carbon, hydrogen, nitrogen, oxygen, but there are about 20 to 25% of the 90 elements that occur naturally that are essential or considered essential. 4 of those elements that I've mentioned several times now, oxygen, carbon, hydrogen, and nitrogen, make up 96% of you and all other living matter. And then we have some calcium, phosphorus, potassium, and sulfur that make up the other 4%. And we're going to get into different things called macromolecules and break those down and see what elements they have in them. And then there are some trace elements that are required by all organisms in small amounts or minute amounts, like iron. Everybody needs iron. And iodine is very essential in vertebrates. It's good, it helps our thyroids to function. Humans require 25 different elements, and most plants only require 17. Little factoid there for you. Okay. And then the last thing for today, I just want to end with this session to say evolution is cool. So sunflowers are plants that can uptake into their bodies lead, zinc, and other heavy elements that would kill most other organisms. So they're pretty awesome there. This helped after Hurricane Katrina when there was a lot of things in the soil, and they could plant sunflowers, and the sunflowers take those up into their bodies and get them out of the soil and get them away, tuck them away and keep them out of the environment. Okay. So I hope you enjoyed this part of our notes. Part B, is coming.